Well, now that Andrew's here, I think we can get started. And everyone, just so that you're observant here, look, the meeting is being recorded. So be careful that we don't wander into any NDA material. Thanks everyone for joining us. Our topic today is the sustainability of ECP software and applications. I'm Susie Titchener with Oak Ridge Lab, and along with my colleague David Martin, who's here from Argonne, we co-manage the ECP Industry and Agency Council, which is a group of industrial and federal agency executives that provide advice and input to the ECP leadership. And this topic of software and application sustainability is one that came out of recent meetings that we had with this council. So we're looking forward today to hearing from Andrew and Mike. Dave Kapczynski, our co-chair of our council, is going to be moderator, and Hal Finkel will be here giving us a multi-agency perspective. We ask that you manually mute yourselves. We're not going to do a global mute so that people can pop in as needed with questions. And we'll monitor the chat for other questions. Please feel free to put your thoughts in there. We'll be looking at it as well as everyone else.
Great. So I will post a box link where all the slides are. Thanks to our speakers for sending them to me so everybody can get to that. We will have about 15 or 20 minutes for each of the talks. We ask that you hold your questions kind of to the end of the talk. Feel free to put things in the chat if you want to make sure we get to it when there's a pause after each talk. We'll have a couple of minutes of kind of clarifying discussion after each talk. And then at the end of that, we'll have about a half an hour where Dave Kapczynski, our Industry and Agency Council co-chair, will lead us in kind of some roundtable discussion with all three of the speakers. So as Susie said, please stay on mute. Earl is our volunteer with us who will make sure that you're muted. And also we'd ask that if your name is not fully in your profile in Zoom, if you could type your full name so we know who is here, that would help us. And if not, Earl will probably chat with you and get you to do it. So with that, I guess, Dave, do you want to kind of get us going?
Sounds good. We'll turn it over to Hal for the first presentation.
Okay, Dave, thank you very much. And let me thank the organizers for inviting me. And I'm going to share my screen. All right. Can you see my screen now?
Yeah,
it looks good.
Good. Okay, so thanks. So first, let me just start off by saying I'm Hal Finkel. I'm a program manager for computer science research in Oscar in the DOE Office of Science. And I'm also here with my hat on as the co-chair of the NITRD High-End Computing Interagency Working Group. And to provide just a brief amount of context on that, let's see if I can advance. There we go. Okay. NITRD is a interagency umbrella organization that sits in the executive branch under the White House Office of Science and Technology Policy. There is a National Science and Technology Council, and under that sits NITRD. And there is a National Coordination Office for Networking and Information Technology Research and Development, that NITRD stands for. And under that, there are a large number of interagency working groups. And these are working groups that have participation from a large number of agencies that participate in research and development activities and other related things. They all have equities in this space. And one of them, the High-End Computing Working Group, is a group that I have the privilege of co-chairing with Alan Sussman from NSF. And we have been putting together a whole series of presentations and discussions and effort on within the working group across all the participating agencies in order to talk about software sustainability. And so this enables me to come in and talk to you today a little bit about software sustainability. So let me share a few things. So first, I've put together, based on some of our interagency discussions, some slides. The order here is by agency alphabetical. These slides are by no means comprehensive. The selection here is in some sense primarily guided by things that have public web links. So we're not intended to be in any way indicative of the breadth of things that the agencies are doing, but here are things that I can point out just to give you some idea of things that different agencies are doing that we can point to publicly and talk about. And I'm going to talk about DOE last because I'll say a little bit more at the end about some of the things that we're doing within DOE, given that this is an ECP panel. So with that, I'm going to provide a kind of brief overview. So the software sustainability conversation within the interagency working group is pretty robust. I'm going to point out that different agencies have a lot of different approaches to worrying about different aspects of software sustainability, shorter term aspects, longer term aspects, both sort of research and deployment. And the nice thing about the interagency working group is that it really enables us to all learn from each other, to learn more about the constraints that each of us have, the lessons that we've learned about things that work well or don't work well, and so on. So I've highlighted here a couple of things. First, from DARPA, they have a number of research programs that speak directly to software sustainability challenges, such as intent to find adaptive software and assured micropatching, which focus on novel technologies that let you continue to evolve software going forward as the underlying systems and requirements change. Another DoD program, the High Performance Computing Modernization Program, they have an effort called CREATE. I have all the links here. This program was actually mentioned by the ASCAC report that our Federal Advisory Committee put together, looking at future after ECP and sustainability of software. And so this is a good example of how we can continue to talk to different agencies and understand the way that they're approaching things. So HPCMP has a program that invests in a portfolio of software and development and maintenance, and they also have a user productivity enhancement and training group, which provides human resources, computational experts that can work with people in order to sustain software and meet their needs in a variety of ways, both with sort of funding that's associated with that program and also with external funding and training. We have participants in our interagency working group from FDA who pointed out that they have a number of longstanding policies on that are relevant to software, which speak directly to sustainability issues. On the flip side, we have colleagues from NASA who have put together a number of efforts, including some that are under a program that's now called Transform to Open Science, TOPS. And TOPS specifically has, as part of that program, funding for improving and sustaining high-value open source tools and frameworks and libraries, and they ran a funding program that specifically focused on that aspect of things. We have colleagues from NIH. Their Office of Data and Science Strategy has specific sustainability programs, and that includes a supplement program that focuses on enhancing software tools for open science. And they also have an effort to specifically put together best practices for sharing research software. And both of these things are part of their sustainability strategy. NOAA, for example, they have an engineering group as part of their high performance computing and communications effort. And they have teams that are being put together in order to invest in the modernization and sustainment of the software that they steward. NSF, of course, has a number of programs that are related to cyber infrastructure and sustainability. There's a program, CSSI, that now has a new tract, for lack of a, I don't remember what the right term is, but it's called Transition to Sustainability, which focuses specific on sustainability. They also have a recent program, it's called POSE, which is pathways to enable open source ecosystems. Again, this is sort of akin to the NASA program in some sense. We're focusing on open source software and ecosystems, and in this case, making investments in the open source ecosystem managing organizations in order to facilitate the sustainability of software. They also have a sustaining infrastructure for biological research program, which focuses on sustainment in that space. All right. So I said I put DOE last. So here's my short list for DOE. DOE, of course, has had investments for many years that focus on things relevant to software sustainability or on software sustainability directly. And we have the IDEAS project, which started as a collaboration between OSCAR and BER. It was back to 2014, right? So this predates ECP. But a lot of that work has transitioned and influenced ECP. And of course, ECP not only has its broad portfolio of software technologies, applications, and so on that it has invested in, but some of them specifically speak to the ecosystem of software, such as SPAC and the SDKs and E4S. And of course, both ECP and OSCAR's SBIR portfolio and other forms of DOE investment directly support commercialization and partnership with industry. There are a number of investments that ECP has made and OSCAR itself has made that focus on research and development of technologies that promise to enhance the tools and techniques and software ecosystem that will assist with sustainability of software longer term. As I mentioned a few minutes ago, our advisory committee, ASCAC, formally recommended that OSCAR develop a program on software sustainability and stewardship. And we released a request for information last year, and that request for information focused specifically on the stewardship of software for high performance computing and scientific computing. And we received a robust response to that. And so those responses and the RFI are linked here. Of course, we also participate in other programs like the Better Scientific Software program that curates best practices. There's also a fellowship now co-funded with NSF that specifically funds some work in that area as well. So this is a brief overview. As I said initially, it's certainly not comprehensive, but one of the things that is really valuable about these interagency interactions is that we get to all talk to each other and learn from our experiences in all of these areas. And of course, each agency has its own unique needs, mandate, and scope. And so, the different approaches are customized for each agency, but we're all learning going forward. And so I think that's going to have an impact, of course, on this community as well. All right, I'm just going to say a little bit more about the DOE and the RFI, and I'm going to specifically try and point out sort of aspects of the community responses which are relevant to our interactions with other agencies going forward. So I mentioned that we released this RFI. This was last year. Responses were due back at the end of last calendar year. And in this RFI, we outlined some activities that were potentially in scope for a stewardship sustainability effort. And we received back responses from ECP, from ECP projects, from national laboratories, but also from nonprofit organizations, from some small businesses, from some large businesses, and so on. So we were very happy with that. We received over 360 pages of response, so we collected them all together. They are a public resource. And I've pulled out a few of the slides here. Again, this is a summary of the responses, so it doesn't necessarily represent the opinion of our office. But I tried to highlight here some of the areas where people talked about things which I think are potentially relevant for partnerships with industry and with other agencies. So one aspect of this is the availability of and provisioning of infrastructure for doing development and maintenance and sustainability of software, including not only the sort of development infrastructure itself, but also access to test beds. And here there are certainly opportunities for partnerships with vendors and with other agencies. Some other aspects of the responses talked about community requirements, looking at how software can be sustained so that it can be applicable to a wider community. Of course, this is quite relevant if we have software that is going to be relevant not only to DOE, right, but also to other agencies and other stakeholders. And thinking about how you support the sustainability of software so that it's useful and responsive to the wider set of stakeholders is obviously relevant to dealing with other stakeholders. Now, we looked at things like barriers to the sustainability of software, and again, a lot of the barriers that were pointed out here were things like lack of awareness and integration with wider ecosystems, and adoption of community best practices, and other things here which again speak to the fact that when you have multiple stakeholders, including other agencies and industry, it's very important that the awareness of what those other stakeholders are doing, the awareness of what the wider community is doing, and the best practices that are required are an important aspect of the overall problem. So, we asked, what the overall scope of activity of the sustainability or stewardship activity should include. And the responses largely validated the sort of set that we had proposed in the RFI, but also added some other things. And the other things really focused on things that assist with the interaction with a larger community, with other stakeholders, with industry, and so on. Specifically looking at things like best practices for community development and management, community outreach and networking, application engagement and support, and legal administrative support. And I think you can see there's a theme there, and that theme is really about how the sustainability of software interacts with industry and with other agency stakeholders, and really enabling that in this wider context. The theme continues here when we ask about metrics for success. There are, of course, both technical and community metrics for success, looking at both technical capabilities and features, right, and also community metrics, engagement and download and enabled collaborations and the like. But of course, we also asked about, and people told us about, assessment, and how do you make sure that the process stays relevant and that things can evolve, stably but responsibly, in order to take account of the fact that the technology ecosystem evolves and people's needs evolve and so on. And again, looking at things like advisory and industry committees, making sure that there's appropriate stakeholder input from a wide set of stakeholders. So all of those things turned out to be relevant, and I think there was a good theme there of really kind of encouraging the community to think about these wider interactions and how they play into the way we think about sustainability and stewardship of software. So I pulled this slide out of the presentation that I gave to ASCAC, talking about our next steps, and because we are thinking about next steps within DOE, within OSCAR, for software sustainability. And these things really come down to sort of defining how we're going to provide funding in the future, what the scope of that funding is going to be, how those programs interact with capabilities that are provided by our facilities and within the various divisions of OSCAR, and then working with ECP and the facilities and other stakeholders to sort of enable a common understanding of how we're going to move forward. So those are all the slides that I have. So hopefully those were helpful remarks, but I'll be here for questions.
Great, great, thanks. We have a minute or two before we move to our next speaker. Do we have any questions for Hal? You may unmute and speak up.
I had a quick question. Can I have the slides?
Yes.
Yes, yes. David, you post in the box, or is
Yeah,
it there already?
If you look in the chat, there should be a link to the slides.
Oh, thank you. That's the answer. Good.
There we go.
I'll post it
Everyone's
again for
slides.
people who joined late. I think that it doesn't always show up for people.
I'm one of the late joiners. That's
All right, I'll post everything again.
Hal, I have a question. How much was part of the responses, I haven't read them, a discussion of how to do, combined agency funding, right? If you have a project which is actually used and developed by multiple agencies, right? How you coordinate funding for such a project, where everybody kind of contributes.
Yeah, that's an excellent question. And I would say in the RFI responses themselves, there wasn't much discussion of mechanisms for doing cross-agency funding, but I will tell you that within our interagency working groups, we have talked about various mechanisms for different agencies to collaborate, to be aware of what each other are doing, and to hopefully share a common understanding in cases where we have common interests. And so, while I think the responses did talk about how you develop software in such a way that it can be applicable and invested in by multiple stakeholders. And then I think we complement that with our interagency discussions about mechanism.
Great.
Al, just to comment, great job on kicking things off with really a framework from which everyone else can talk to. You mentioned the shared challenges. Continuous learning is an important part of this. These transitions between teams and organizations and maintaining business continuity. I'm glad you mentioned Oscar and ASCAC and also the RFI and partnership around software stewardship. And then the interagency kind of broad view, but with detailed information. I think this is a great deck where coming out of this, people can relook at the information and reuse it based on this sustainability framework and how things are currently working interagency. So thank you.
Okay, yeah, thank you, David. And I'll just add that our interagency working group is working on putting together a white paper that sort of captures all this in a somewhat more comprehensive sense. So we're hoping to be able to finish that up and get that out as well.
Super.
Great.
Thanks, Al.
I think, Dave, we will move on to Mike Haru. Mike?
Yep, I'm here. Hang on a moment. All right. So thank you also for the invitation. This is a great discussion. So just a bit of an outline of and there's so many things a person could say, and I'll just try to hit some highlights of things that strike me. And so this is a bit of an outline, something we're sustaining: better, faster, cheaper, measuring progress, building communities, and then a vision and organization going forward. So I think this is a prerequisite. If you want, for sustainability, you have to have something worth sustaining. And I thought I'd just provide a kind of little bit of an insight into the dynamics of how within ECP, and this is broad across a lot of DOE software teams. How does new functionality get created? And in a lot of instances, it's developed in a kind of incubation phase between a product team, say a solver team or a viz team, and they work with their application partners who need new capabilities. And so they do this kind of off to the side and play around, and they have some awareness of what's in the literature for algorithms that could be useful. But then it's really about customizing the capabilities for a user that hopefully represents a a broader set of users. And then they take that once they've done some exploring and that there's a there, they can harden that, and then they can deliver that and then eventually deploy it in a kind of sustainable way. And so this kind of activity is very common across teams. Now the players may change depending on what area you're in. We're kind of going through this mental model process, in the tools area, in the LLVM ecosystem, and trying to identify, who the players are, who the dynamics, or what the dynamics are, among these players, so we can have a deeper sense of, how to characterize what we do and plan for that. And these are just a few examples from the Nalu Wind team and Hyper, some of the things that were done to improve the scalability. In this particular case, the pressure Poisson solve that was part of this segregated CFD aeroelasticity type of problem. And then sundials and Ginkgo, a similar kind of thing. You're looking at algorithms, work for batching, lots and lots of small systems that are all independent. And then in Alpine and VTCAM, contour tree algorithm. So these are very specific features that are being developed for a specific team, but then have broader applicability. And this is the kind of dynamic that goes on among our teams, working with the clients, the eventual users of these capabilities. And so what are some takeaways from this? New development of new useful software capabilities is key, and then integrating that into our existing stack. New science drivers and algorithms and hardware provide the impetus to develop new software, and a lot of this work requires a kind of shoulder-to-shoulder interaction. So we talk about sustainability, but I think this kind of rough characterization of how does something worth sustaining get created is worth keeping in mind, because we have to then support these activities if we want to produce anything useful to sustain. Okay, then a little bit about faster and cheaper, better, faster, cheaper sustainability, or an ECP, ease, cost, scope, and schedule are the terms we always throw around. So one of the big factors in better, faster, cheaper for software technology is E4S, which is this portfolio approach to managing the capabilities that all of the software technology teams are developing. We use SPAC as the foundation for the meta build tool, and increasingly for other features like build caches and testing of little testing features, portfolio oriented things. It's also the signal for how a team that, say, has a new set of features they want integrated into E4S, the way they communicate that to the E4S team is they create a different, they revise their SPAC recipe to point to the new version of the software. And that's an implicit communication of, hey, we've got something new to put into E4S. And so SPAC is a really important part of that. But there are a lot of other things that we do, and I'll go through just a few of these things. We have community policies, we have the doc portal. Howland mentioned in his presentation, how do people even know what's going on? And what we're trying to do with E4S is provide a kind of a portfolio level signal of here's where you can find stuff, and here's how you can use things. And this slide's a little out of date. Our most recent release was in February. We'll have another one coming out at the end of this quarter because of the quarterly releases. So I'll just go into a few of these things. So as I mentioned, SPAC is this kind of backbone of how we build our products and manage the portfolio. And the reason why I mentioned that also, and I'll mention this, we have a talk on kind of coming a little bit later in the day, is that SPAC is kind of an on-ramping tool. If you invest in it for your ecosystem, it makes it easier to interact with our ecosystem. And so it itself is a kind of expansion and sustainability across a broad set of products, even things that you develop or don't develop yourself. E4S and the SDKs are platforms and in a software ecosystem sense. And you know, Hal had mentioned the POSE open source ecosystems effort that NSF is having or supporting now. And the SDKs, the software development kits, where things like the math libraries, the Viz tools, the IO tools, each of them has their own SDK, is a way of trying to create these ecosystems. The SDKs are specifically oriented towards development teams that need to collaborate with each other to explore design spaces. E4S is more the comprehensive, and you can think of them as a hierarchy. E4S can build via the SDKs, and the SDKs build the subset of products that are a part of their smaller ecosystem. These platforms, provide a lot of value to the teams that participate in it. It's part of our sustainability. It's part of all three: better, faster, and cheaper. Robust engagement in the SDK and E4S gives you all three of these things, with certainly some cost, and we need to manage that cost. It costs something to be a part of these, but we hope that the value proposition of being part of these is well worth the cost of that engagement. Another way of better, faster, cheaper are a set of community policies. What are the expectations on the teams and the products that are part of E4S? And this is our version 1 of the policies. We anticipate in the coming year to generate the next version of these policies. We've learned some things from using these. We've made progress against them, and can we refine them and maybe add additional ones that will further elevate quality expectations. All of these policies drive team behavior in a way that's generally positive for the community, for the team themselves, or for their users, or for some combination of the ecosystem. And we've seen a lot of positive impact from setting the expectation of what it means to be a part of E4S. And then the last thing I'll mention in this area is the E4S software stream. And this is working with the software deployment team and the facilities, and that creating in a sense, a kind of freeway, if you will, for once we incubate software, as we harden it and we deliver it out to the users, can we do that again in a streamlined, portfolio-driven way and improve the quality of the work and detect regressions, by testing as a portfolio. If a new version of the vendor software comes out and it creates something in our stack to crash, because of a problem with a bug in the software or missing link, we can detect that and fix that in a way that doesn't require each team to struggle with it independently. Okay, so a little bit about measuring progress towards sustainability. I personally am, and I think in general, we're quite enamored of what we call KPP3 for ECP, which is the key performance parameter for ST products and for the co-design teams. And because we believe it describes and measures the fundamental value proposition of reusable libraries and tools, is that they are integrated into the client environment in a way that's sustainable. And so we have a whole system around defining that and tracking that and assessing progress. And I think that's very important as part of sustainability. It provides a layer of transparency to the activities that we're doing and gives us a kind of assessment process into things that are going well and things that might need help. We can use this as a way of saying, oh, great, you're making good progress. Or we can say, oh, things seem to be slow. What can we do to help you? To improve your integration. And so, developing these kinds of metrics around sustainability, integrating capabilities is very important for us. And then building software communities and workforce is another area where I think we need to continue our efforts as a part of the sustainability that we're doing. The IDEAS project, which I think was mentioned already by Hal, certainly the BSSW part of it is central to the ECP, and even before ECP, notion of how can we create community, how can we create a sense of professionalism around software activities, that we do within ECP. Moving beyond ideas and in a sense very closely connected is a new effort that we call Leadership Scientific Software, LSSW, where we've been hosting monthly meetings. Again, the idea here is to provide a forum for people who are interested in what we call leadership, but you think of it as kind of where there's a gnarly design space that you have to explore and develop in, where we can get together and talk and learn from each other about our experiences and how we might go forward with this. And so this is a series of meetings on a variety of topics related to leadership software and how we might go forward. Also, we are exploring, additional skill sets that we want to add, again, as part of our sustainability. As scientific software becomes more complicated, and as we get a greater sense that software is for people, that software as we design it should adapt to people and communities more than designing a piece of technology and then having people adapt to it. I think is a greater sensitivity around what we can do. And so in what we foresee as we go forward is in introducing social and cognitive specialists, in addition to things we've already added over time, as we've created communities of development teams. And so we explored that at this workshop on the science of scientific software development and use. And we have a bunch of white papers that were collected and that are accessible. We also have a brochure that's almost ready to go out that defines what the findings of the workshop, and then we'll have a more full-fledged report. So all of these things are important, I think, trying to build a sense of community and set a set of career paths that will help people want to be a part of the endeavor, because you can't sustain something if you don't have access and retain good people to do this kind of work. And then the last thing I'll mention here is that's coming up next week is we have community BOF days, which is again is trying to build community and by making accessible the teams that work on our capabilities and having open conversations about what we're working on and getting input from the community as a whole. All right, so it's just a little bit about the takeaways. So I threw a lot of acronyms at you. We have the ideas, SDK, E4S itself. I didn't mention the RSEs, but research, software engineering, BSSW. All of these things are components of what we're trying to do to build a robust community around scientific software. So just a little bit about a vision and organization going forward. One of the things we're exploring right now and that I'm excited about because it gives us an opportunity within ECP to change and augment the business model for how we support and sustain our software. If you look at before E4S, before this portfolio approach, if you had a DOE app developer and facilities user, they had to work directly with a DOE library and tool developer. That relationship doesn't go away, but that's all they had at the time to work with, say, a library or tool that was being used. They had to know who to go to get access to it and who to talk to get support. We've been able to fix that and elevate that kind of relationship. You had to work directly with facilities and user staff in a very specific way. And anybody else outside of these three entities really didn't have a role that was easily brought into the community or the ecosystem. By adding E4S, we have all these old relationships, but we also have some new ones. And it enables this portfolio approach. We can integrate delivery and supportive tools. We have a single point of contact for planning and issues, so we can go as a team, E4S, and talk with the facilities and talk about what do they need and what can we provide in aggregate, representing all the teams that are part of E4S. So it elevates the conversation in a way that wasn't possible before. The new thing we're adding, and it's actually in place now and we're just ramping up, is a commercial E4S support team. And by this, what we're able to do is bring in a commercial entity that can help support users of E4S by doing what we call tier 2 support. So if a user at the facilities is trying to use one of our products as part of E4S, and they run into an issue. If the support staff at the facilities can't fix it, what they do is they turn around to the E4S support team, and that team takes over at that point and either tries to fix the bug because they know E4S pretty well, or work with the product team that owns it and resolves it and takes ownership for resolving it. So that's how it helps, internally within the DOE facilities. Externally, what we hope for is that because there's now a commercial company that knows the E4S products and could be commissioned to work with an external agency or corporation company, is that there's someone to answer the phone. Because one of the things we've consistently heard from people who are outside of DOE is that an impediment to use of our software is they don't have somebody they can call and expect support from. We will do our best. All product teams want their things to be useful, but they can only go so far in terms of supporting somebody who's not directly funded to work with the DOE teams. And so we're hoping by bringing in this commercial entity that we can do two things. One is we can distribute the benefits to a broader group of users, and we can distribute the costs associated with the software and hopefully benefit everybody in the community. And that goes a long way to improving sustainability of what we provide. Very long term, this is notional, but if you've been around other ECP meetings, we have this notion of a leadership software center. This is completely notional, but we needed some kind of framework to start reasoning about. Well, let's say we were able to bring up a software sustainability and organization. What could it look like and what would it do? And so what we're notioning, the notion here is that we would have some kind of base level organization. And then on a periodic basis, every so many years, we would initiate a campaign that would focus on the next set of application requirements and making sure that we can provide good software, reusable libraries and tools, for these next set of applications, and then manage it through, a change control process, much like ECP did, so that if, an emerging requirement comes up quickly, in the middle of a campaign, you can still adapt. If something that you thought was important is no longer important, you can off ramp that as needed. But having some of these, this kind of an organization, at least to us, seems quite attractive. All right, closing up then, what are the requirements for sustainability? Well, something we're sustaining. Community tools and processes around the E4S portfolio allow us better, faster, and cheaper. And then the KPP3, or the sustainable integration of capabilities, is very important. And then communities, career paths, and collaboration. And then the E4S support model, we're really excited about it. I'm hopeful that in the next couple of years, we can establish this as a really nice business model. Within the computing systems community, as we stand up leadership systems, we have very nice commercial partnerships with, HPE, Cray, Intel over the years. But we've never had quite the same kind of relationship when it comes to software that doesn't go with the system itself. And that's what we're exploring here, and hope will develop into something really meaningful. And I'll stop there.
Great. I think we have a couple of minutes here for questions. So.
I think we have one.
We had one in the chat, didn't we?
Yep.
We do. Christian, do you want to just unmute and ask, or do you want us to read it?
Yeah, sure. So I think this, a commercial support, on the site, I think is a really good idea. But if you have a commercial E4S team, right, it probably doesn't have much detailed knowledge about the 100 products or so which are in E4S, right? So it probably can't actually fix problems in the products underneath, right? How would resources be made available to address that, right? If something comes from another agency or an industry partner or so.
Right. Yeah, I don't think, if there's a real bug in Cocos, at scale, for example, I don't think an E4S, commercial E4S team will necessarily be able to fix that. But that's something that you would want to fix anyway. What they can do is they can, work through all the other possibilities for the bug, and eliminate those as likely possibilities. And then, they only have to hand off to you the things that are most likely true bugs, which are the things that you want to fix anyway. So it's not an all or nothing kind of thing. I think what it is it tries to reduce the cost of addressing bugs as they come in. They will also very likely see, common themes across bugs. They'll see a bug that comes in from somewhere that smells or looks like one that was done before, and they may be able to quickly identify what fixed the previous one. So I don't know. Again, this is based on a lot of years of seeing how this kind of activity occurs and how it can potentially be improved. The processes can be improved. I see Carol has her hand up.
Yeah, so in this vision that you have with the commercial entity, agreed that there could be some real benefits in handling kind of that first line of things. But I do worry about a level a level that kind of retards communication between the developers of the packages and the people who need to use them.
Yeah.
Often when we're talking with a user about their bugs or their issues, it turns out it's not so much a bug, it's a way that they're looking at the problem that makes the way they're trying to use it, or a common way of using it, not the best fit.
Right.
And so that interaction becomes really important that we have with them in two ways, right? Because it helps us explain to them, how to look at things that might be more efficient for them and how to more efficiently use the package. But then also it helps us understand where they're coming from and what their use case is much better, because there's probably nearby features and things that we wouldn't necessarily have heard about any other way other than that interaction. And so I worry about that chance to really interact with the users and losing that ability.
Sure,
even a one-off conversation.
I see that as a risk, and that's a risk that we would have to try to manage as we go forward, and make sure that that you do get the kind of input that you want and need from your users. But yeah, that's a real risk.
Cool. And Craig, I think, had a question.
Yeah. Mm-hmm.
Yeah, and I put it in the chat. One of the, I don't know what your kind of support model is going to be on the commercial side, but those kinds of things have been around for a while. And I pointed to something obvious like Red Hat's support of, generally speaking, an open source operating system. Yep. Is that kind of the model that you're thinking of here?
Well, so we work on kind of boutique systems a lot of times, right? And so right. I'm not sure that that everything that Red Hat does for commodity x86 systems makes a lot of sense for us. I think it requires a little bit more of a a one-to-many model is not necessarily the right model. A one-to-few or one-to small community model would probably be more appropriate.
Yeah,
but again, there is some scaling benefit. Go ahead. Sorry, Craig.
No. Yeah, I think you're right, Mike. And especially, because many of us, my area is in molecular dynamics, and I don't want somebody on the phone that doesn't know anything about what I'm doing, right? So that makes perfect sense. So I think a kind of a, how can I say it, a pipeline or a, some kind of approach like that makes a lot of sense. But I was just offering it up that you were actually, what I meant by the Red Hat support was not the extensiveness of their support, but rather, some kind of pricing model based on that.
Yeah, we're not out, so I'm not out to make money. I already get paid for this work, but right. But it leaves the door open, right, for some kind of or other, industry partner or other agency to potentially use what we're having and get the kind of support that they need. They can pay somebody to answer the phone. And they can't pay us, right? They can't pay us at the Department of Energy. It's harder, at least. right? We can't, we can do joint funding as Hal was talking when answering a question from Christian, but otherwise it's hard.
All right, we should probably stop the questions there. We'll have a half hour at the end here for discussion. And Andrew's way ahead of me here.
Okay.
Perfect. Take it away, Andrew.
All right.
Introduce
Yeah.
yourself and then.
All right, so I'm Andrew
go.
Siegel. I'm the Director of Applications for Exascale Computing Project. And I'm going to talk about sustainability from the perspective of applications, which is quite different. It's actually very difficult for me to talk about because it's hard to generalize. There are applications which on one extreme are a little bit like software technologies where they're very robust and very general physics components that might have a broad user audience. And they might be treated in a sense similar to what Mike describes. And there are things all the way on the other end of the spectrum, which are full of heuristics and targeting a very narrow sub-community and set of problems. And they'd be handled in a very different way. So I'm not really putting forth a vision here. I am making some distinctions and throwing out some thoughts as a catalyst for discussion. And hopefully, as a group, we can make some progress after I give my talk. So first, what am I even thinking or talking about when I'm talking about sustainability for applications? Well, I'm talking about this in a very general form. Just we've made tremendous investments across the 7 years of ECP, and what I will refer to in a second are 24 different application development projects in domain science or engineering. And what is the strategy post ECP to leverage these investments so that these applications do productive science or are sustained at least or evolve to do different things in the future. So I'll first point out, as I see it at least, again, everything I say is a generalization to which you can find an exception. I'm sorry, but I just have to speak sort of for the most typical case. Science applications have some fundamental differences from enabling software technologies. And to first order, at least, the primary focus of the application is always to gain insight into a particular class of physical phenomena. It could be something that is general across many domain areas, or it could be very particular, to understand heat transfer at the boundary of a fuel pin in a nuclear reactor. I mean, it can range a lot, but typically it's driven and led by the desire to answer specific questions, not by the tool itself. Running the simulation is typically the starting point, not the end goal. Okay, so we put so much of a focus on getting codes to run on exotic hardware efficiently, often including verification and maybe even certain aspects of validation. But even that is just the starting point for doing something totally new that requires really ideally, months and months of analysis and interpretation and thought to see how you could make use of the results that you're getting. And that, I think, is fundamentally different from something that has more clear defined inputs and outputs. And I'm not saying these are all or nothing distinctions, but I think it is sort of a different use case and a different model that distinguishes them from software technologies. Applications typically aren't robust. They're just full of heuristics, right? And it's the heuristics that couple the domain to the sort of computer scientist and the mathematician, the domain expert, because you can't often reduce it to just a differential equation that you discretize with a technique that has known convergence properties, and then you implement with methods that are well understood. It's not really like that usually. Usually there are lots of approximations that have to be made, and better or worse is often defined by what you want to get out of it and not by something that is mathematically superior. Right, so I'd say this is probably less common. And what that does is it requires expertise to use. Okay, so that sometimes limits user communities, or it makes the interactions between the developers and the users much more time consuming because it's not clear how you could avoid using it in ways that it wasn't intended to be used. And it also means that very rarely is a code ever finished. So I wouldn't think of ECP ending and you're finished, and now how do we sustain what you finished? You're constantly, as you use the code, learning more about its limitations and its abilities and thinking of new things to try and changing things that didn't work the way that you intended them to work. Okay, so I do see these as, at least in the typical case, quite different from each other. So I can imagine sort of two broad forms of support post ECP. One is what would happen naturally in some cases with no guarantees, and that is to do science. So FOAs that are science focused and that leverage the developments of ECP, with the primary goal being publications and discovery. So teams that will have participated in ECP will have a very good chance of being funded to do discovery in, material science and fusion, fission, accelerator science, whatever the area might be, because of the head start that they have for having done all of the development work over the past 7 years. And then there is sort of a more hypothetical type of support, which would explicitly be for sustainability. So even if nothing new were added to the code in terms of capability, or there were no changes that went very deep into the algorithms, for example, even to support, train, be able to port to new systems, be able to fix problems as systems evolve and new versions of compilers and runtimes, so whatever the case might be, that implies a certain amount of effort and dedication that could enable broad adoption in certain areas that wouldn't happen for very long without it. And I have experience in a couple of projects where things kind of went fallow after a couple of years because of no additional sustained funding for that type of thing. Then, of course, there can be things that are explicitly the mixture of the two. So none of this addresses details that people really do care about within the project, like what would the level of investment be compared to what it is now, and what is the length of the commitment. I mean, one of the nice things about ECP was there was sort of a 7-year horizon that allowed people to prioritize and schedule their work in different ways that allowed, in a lot of cases, faster progress. So these are important details to consider in a real plan. And then, of course, raises the question of sustainability for whom. And it implies external users, but it could also be the case that you have a code that is just user developers, and we have both. And the requirements might be very different for each case. Oftentimes you have something in between where the developers are the users of the code, and they might have a handful of collaborators in the community who are working on the same thing. Okay, so those are just some thoughts. Let me give just a second of background. I referred to 24 application projects. I should be clear, 3 of them are within NSA, and I think the vision for sustainability is much more coherent within NSA, and it's all part of a common set of use cases and drivers. So I'm speaking mostly about the 21 science applications, which are more complicated in ways that I'll explain shortly. But in any case, and this includes 78 what we think of as different application codes representing. I mean, lines of code don't mean that much because you can count in many different ways, but that was just sort of my best count going over them at one point early in the project. And the idea was that these covered a broad range of mission critical science and engineering domains critical to ECP. Some support relatively large user communities, for example, quantum chemistry, even within astrophysics. Obviously large is still relatively small compared to what you would expect for enabling computational technologies, but bigger than you might imagine, thousands down to hundreds. In other cases, we have codes where the people who are doing the core research are the code developers, and a lot of the innovation of the code are the methods for the physics that they're trying to simulate and understand how well the simulations are working. And it's all part of sort of a research loop, right? And I think in almost in all cases, there is interest in people using what's developed, whether it is more of a community code project or more of a developer equals user project, but they don't all fit in the same category initially. And the way this is sort of envisioned is that these application codes, for lack of a better term, were kind of borrowed within the ECP project as guinea pig exemplars to lead the way onto exascale machines. So within ECP, they're very much code artifacts that are heavily involved in, for example, code designing all aspects of the system software, even software technologies, compilers, as well as helping to understand and lead the way and kind of pave the way for performance and performance portability, ideally, for a large other generation of codes that come behind them. Okay, and so they all went kind of through the cycle over the past 8 years of starting with many multi-core or then maybe many core CPUs, then CPU plus a single GPU, then porting to CPU plus multi-GPU architectures. And then there's a sort of shift to GPU residence as 97+% of the floating point performance was accounted for by the GPUs. And then we moved, as we finally saw what the exascale machines were going to be, to a diverse multi-GPU architecture with NVIDIA, Intel, and AMD accelerators. And then we're sort of in the stage now where people are doing a lot of architecture-specific optimizations, especially as they're realizing some of the deeper differences between the MI250X and the A100 or even the MI100. Okay, all with the target of running on Frontier and Aurora. But this is all done not just as a porting exercise, right? It's porting plus new physics plus new algorithms that are valuable even on CPUs. And they're all pointing toward not a toy problem, but a problem which is impactful and has been vetted in their particular field. Okay, and the last thing I'll say before I address the question again more directly is the choice of programming model deeply affects sustainability. And this is another lesson I learned 25 years ago with my thesis, when I was kind of caught in the transition between how I wrote my code in PVM and MPI, and everyone sort of had this massive push to switch whatever parallel programming distributed memory model they had to MPI. And it was a lot of work, even though they were roughly isomorphic in the details. It took months and months of time that I got no credit for in front of my thesis committee to do the code transition. I say that because we have an ecosystem now that's unclear and that's evolving. And I show migrations throughout the course of ECP of code starting in one programming model, jumping ship, whether it's from Fortran to CC++, or whether it's using OpenMP and shifting to Raja and Cocos, or whatever the case may be, people kind of hedging their bets and shifting and probing and wondering what their choice means for how long it will be until they have to do some serious work to make the code sustainable in the future. So it's kind of an interesting time in that sense. Okay, so I'm going to throw out some discussion points. I'll just tell the story directly. ECP obviously represents massive investments in each of the, I'm thinking particularly about the 21 domain science application areas that actually varies by application, but includes over $20 million per application over the lifetime of ECP. So this naturally calls for a plan to leverage these investments post ECP, not to put all this money and then have no idea what could come of it, or to sort of even leave it up to chance whether the investments yielded all sorts of progress down the road. As I said earlier, it's not really realistic to think of codes as finished and made available for use. Now, you could say as far as they've gotten, which is being able to accomplish their challenge problem, is significant, but you still need at minimum a sustainability plan if you want them to be impactful for their user community or for the user developers for, let's say, the 3 to 5 years that the exascale machines are around and whatever's coming next. So the question would be, what would minimum application sustainability require? And then who would do it? Well, traditionally, I would say most application development teams are happy and understand that part of their research also involves some of this type of work, but it can't be the majority of what they do. And as the user communities grow, obviously it becomes unsustainable. So some thought has to be put into actually how that would be executed. And what would the investments look like if it wasn't just pure sustaining the code, but it was sustaining the code plus different levels of innovation? And innovation can be defined very broadly. I mean, in the details, things can become very sophisticated just when you have new features of a programming model and you want to know how you might exploit them to increase performance, for example. So, could some apps on one extreme of the spectrum be supported similar to a software stack? And is there any single centralized office or agency that could be responsible for at least a base level of support? Because, as I'll mention in a second, now no single entity owns this broad spectrum of applications. They're seen as via collaborations or spread across agencies and offices. So I'll make another point, which I think is maybe the most critical, which is sustaining apps also largely in ECP means sustaining everything that Mike talked about. because there's been an, I would say, total shift in the uptake of enabling computational technologies within application development projects. And maybe part of that was catalyzed by the project nature of ECP, but it was still a bottom-up effort. It was never a managerial construct. It was, I think, recognizing that the new machines are difficult and you can't do everything yourself. And there are people sitting right next to you who are working on hard problems who can do it better than you can in many cases. And so because of that, this shift from, I would say, how things have done historically, and again, I'm generalizing, I realize, but I think it's a fair generalization. The software needs to be around for the applications to be sustained. Okay, so who is going to be responsible for performance porting, improving and adding new features as applications might want something slightly different, even just fixing bugs of all of the math libraries and IO libraries and everything that these applications have adopted from the software technology portfolio. Okay, and as I mentioned, sort of the organizational problem that I'm not in a position to address, but I'm happy to point it out, is that applications are not seen as owned by Oscar, right? Oscar is the major funder of ECP. They're kind of borrowed for this particular purpose. And it's even harder because ECP applications do not belong to any single centralized sponsor. So they're spread across many offices and agencies. It's not just in DOE, it can be agencies outside of DOE as well. And so there's not going to be a single overarching vision for their sustainability. Even scientific sponsorship agencies typically provide support to solve new problems, not to support users, text codes, bug fixes, enhance performance, and do outreach, et cetera. So these activities are, as I said, often implicitly absorbed into the budgets when they become big enough. So when I've been on projects that are sort of $5 million a year, then there's enough extra money around to be able to hire research software engineers, or which now that title has sort of been, I think, elevated and gotten the respect that it deserves more. But I think at the time, it was just sort of coming into its own. But even people who do documentation, but is that enough? And despite all of this, successful community codes do exist, often by the heroic efforts of a small number of individuals. But I think the question is, how can we do better? Okay, so my last slide is the one
in just a
obvious-
minute more, Andrew.
Oh,
if
I
you,
have a minute. Okay,
well,
I cannot believe
yeah.
I talked that long. I was going to say I could do this in 3 minutes. Okay, so one decentralized solution is a ground level effort to match applications to DOE RFPs. There'll be some successes and failures, but there are a bunch of programs now that are partnerships between Oscar and other agencies where a lot of it was done in ECP would naturally fit. Although this isn't part of a strategy necessarily, I think a lot of sustainability would happen through these types of programs. Okay, and I'll just leave it there. Okay, if we have time for a question or two, I'll take it.
Andrew, thank you. Lots of meaty stuff to think about. So questions, there are a few in the chat. Rick, you had a couple. Do you want to unmute and ask?
Yeah, and actually, I think Dave could probably pick them up and drive them a bit better. This is just relating to what is a strong trend right now that we're seeing in the Department of Defense supply chain towards model-based systems engineering, which kind of pushes towards standards for data exchange and then functional interoperability in standard and arbitrarily composable ways. And the DoD's perspective on this is wanting to have more, modularity in being able to use model-based assessments toward, qualifying acquisitions and things. These are the sorts of ways that industry would start, looking at these applications, or even the software stack is helping to support that and our use of modeling and simulation in product design and integration. And Dave, you can maybe clarify this a bit more, but this is something that has rapidly been shifting recently, and I think is a great opportunity for this ecosystem.
So that's actually kind of a good lead into our roundtable. I know a couple of people have their hands up, but Dave, I'll hand it over to you, I think, for.
Let me start off just by framing this up, and then I'll go to a couple of folks that have their hands raised. Please keep your hand raised. I'm going to throw the first question out there, but I'm going to do it a little bit in summary form, and let everyone know that we started off today with a framework and saying that we have shared challenges that carries throughout each of the topics today. First around the framework of sustainment, then around software technologies and applications. And Andrew, and you know this, even your challenges are the same shared challenges amongst the other team members, even if in the in the application development, things are different, and they are different. They should be different because the focus is different. I do want to mention here that from an industry standpoint, I won't talk on behalf of the agencies, my other co-chair, Fran, but what we do from a framework standpoint is we have a product management framework that encompasses the life cycle and sustainment. So product management, we have product leaders. The product leaders are over the software technologies and applications and hardware and infrastructure. So product leaders for each of those areas. And all of the things we mentioned today are then under that framework around the development, the validation, deployment, enhancements, integrations, interoperability, operations, support, training, because these are all important for the life cycle management and sustainment. To be able to take closed loop learnings and bake them back into the enhancements and innovation and product development, we need that framework around it. In order for us in industry, security is paramount. So in order to manage security management on an ongoing basis, which is really daily, weekly, monthly, we need to be able to have that product management, life cycle, and sustainment framework. And then the big thing that transcends everyone across is continued investment, financials, and the resources. How it's organized is typically by the framework constructed, but the resources in terms of support, essentially land toward what the users need. And then from the user perspective, that trust in that framework that's been developed for sustainment, that trust in being able to go to that product, whether it's a software technology or application, be able to use it, reuse it. When I find things, I have the right people to support it. That trust builds in the collaboration and usage of those products, whether it's just a few users, or in some cases, hundreds or even thousands of users. And then we didn't talk about it much today, but I love the discussion, which both Andrew and actually all three presenters said this, what's worth sustaining? Because there's a worth around it because we're going to put money into sustaining it. And what are those software technologies and applications that are worth it from an outcomes and impact standpoint? Notice from my end, industry typically talks in terms of business value, but outcomes and impacts are the same for the both of us. Your outcomes and impacts are, scientific and engineering challenges of, epic proportions. And then for us, you would say it's the same in terms of like the business value that we're trying to generate from what we're doing here. But what's great is around the just plan for continued investment and the plan for sustainment is important here, because I think that the teams are doing things to look forward and forward thinking, not for just the near term, but I heard this throughout each of the presenters, the long term. So I wanted to just stop there and frame it up and say we're more alike than we are different. I am interested after the first couple of questions, and I'll let Mike and Andrew and Hal think about this, but in saying that we're more alike than different, what's one or two things that in your area, and you listed it in your presentation, but you just want to surface it right up to the top, that are the most challenging to you in the long-term sustainment model? What are the 1 or 2 things that are the most challenging to you? And then with that, I'm gonna go to Amitava, who has your hand raised. And if you could just go ahead and ask your question.
Thank you, David. My question is primarily directed to Andrew, but though I really enjoyed Mike's and Andrew's presentations, both of them. It's a pity that the ECP or Oscar takes such firm custody of the STs, but much less so for the application projects. I wish that were not the case, frankly. Throughout the life of this project, I had hoped that the outcome would be different, but it is what it is. With that said, I wanted to pick up on a couple of things that Andrew actually mentioned explicitly. So I have 2 questions, and 2 are rather different. One is that you mentioned, Andrew, SIDACs as a possible avenue, just a possibility of taking custody and supporting some of these app projects going forward. Now, it turns out that the SIDAC solicitation for most offices in the DOE Office of Science went out already. And I do not have but the fusion one was postponed by a year, and it'll come out next year. So I don't know what the FES will actually do in continuing what we are doing with the ECP. But I wanted to ask you, from your view of the SIDAC solicitations that have gone out from other offices, has there been a partnership between the ECP and through Oscar and these offices to which you report to, on how this will look going forward with some of the other app projects that we could learn from? That's one question. The second one is a bit along the lines that Dave has been talking about, and this is coupled to the issue that you raised, Andrew, namely that within labs, if you want to build up, say, a software engineering component of people, these are not so easy to come by in any but the major laboratories that are part of the ECP, and important work is going on. So what we're finding practically is that companies are interested. We have an example of such a company working with us to bring such expertise to our products. But then there is a little bit of wrestling regarding in a open source code, how much IP they can really claim. And this really becomes then in conflict, if you will, with the one hand, this industrial groups having the suppleness and the quickness to respond to needs, on the other hand, being compromised on the very things that bring them profit.
These tile sizes, but this is just for illustration. You can easily play one of the tile sizes. In this case, on an NVIDIA.
Okay. That was, I think, an extraneous voice, if I am not mistaken.
Yeah.
But I leave it to the experts now. My 2 questions. Thanks.
So I'm probably not the most qualified to talk about SIDAC. I'm not even totally clear what the question was, but it might be better for Hal to pick that up. Not to call on you, Hal, but
Yeah. So, yeah, I mean, obviously, I mean, I'm not going to say all that much in response, except for the fact that we have an ecosystem that has many stakeholders, right? And so it's really important that people are invested in the things that are core to their missions, and that's the thing that we have to enable. So while it might be like it might seem desirable to have a kind of one-stop shop for all things, the reality is that there's going to be a certain level of distribution and kind of a multifaceted aspect to the overall sustainability process, just because there are a lot of different stakeholders and they all have to invest in different ways.
Let me make my question sharper. What will
Yeah.
Oscar specifically be willing to do? Very simply, that.
So, on sustainability in particular, that's something that we are actively working on. And so, we have not announced yet, what our plan is going to be or precisely what its scope is going to be. I think, that you started off your question by asking about, applications in addition to, software technologies and libraries. And, one of the pieces of this, which is, both an exciting opportunity and also complicated, is that there are many stakeholders, especially on the application side of things. And so, one thing that I think is certainly true is that, whatever the scope is of what Oscar can do, we hope that that establishes best practices and a model that, if successful, other people can buy into and follow and scale up. So, we would like to encourage, right, that healthy ecosystem, and then, and then go from there. But I mean, in terms of exactly what we're going to fund and what the scope is going to be, I can't comment on that yet.
Yeah, and I mean, I am not sold on outsourcing the software engineering component of a multi-physics application project. I understand it's difficult to attract and retain software engineering talent in a smaller research environment. And one of the things that I mentioned that we talk a lot about these days is the sort of elevation of the position of research software engineer in the community, and just the coining of the term, so that there's kind of like a home and a place and an identity associated with people who do very sophisticated code development that touches on aspects of physics, applied math, and interesting computer science, but doesn't necessarily qualify as traditional research in any one of those particular areas. Those people, especially if you're endeavor to do something like you are, Amitabha, which is create a community whole device model for fusion. Once you start to tackle something big, something coupled, something that other people use, those issues become more and more important. People who really understand aspects of software design in the presence of performance, and who have this broad set of skills that can help domain experts pull something like that off. It's interesting, the thought of bringing people in from the outside. I think it would be an unfortunate model for the long term. That's just my opinion. I think we could do better as institutions to be able to sustain and elevate and define these positions in such a way that we can attract and retain that type of talent. And it's honestly, the opportunities abound. So at a lab that has a number of different things going on, I understand PBVL is a little smaller, but still they wouldn't be wanting for work ever. So, that could be on us to elevate that position in such a way that those people can be parts of these projects. That's just my take.
So thanks, Andrew. And we'll wrap up that question. And I saw another hand up, Uday Korde.
Hey, Dave. Yeah, this is Uday. I just typed my question in because I think great discussion. I was beginning to lose sight of what I was going to ask. So I typed it up. I must say that I think there's been great progress in this sustenance and support since the couple of annual meetings that I've attended in the past. So I really want to applaud the team for putting thoughts into that. And now I understand a little bit better on how the ECP ecosystem is coming together in terms of software technology and applications and stuff. And I can also begin to understand, I think, is it Andrew who said that, these tools are being brought together to solve a specific problem. So they are not like a commercial tool like Fluent, which can solve all kinds of problems, right? And I appreciate that. And I think really we want to take advantage of that. And so what we would need in terms of industry, I'm not speaking for everyone, but I think it may be common to everyone, is what kind of support we would get to form that unique combination to create the tool that would answer the questions that we want to ask. And how would that be sustained going forward? Would there be a commercial entity that would then take over and be able to support us in the future? Because, we are looking at life cycles of products that go into future years, right? 4 years, 8 years, 10 years. And so that was my question in terms of what kind of thinking you put in supporting industry in that fashion. Thank you.
Uday, I'm going to combine your question to not simplify it and not confuse anyone, but are there plans, either Andrew, Mike, or Hal in any of your spaces to not only productize, but go beyond productization and commercialize And would that be from and through your teams, or would that be potentially with some partnerships with, industry or other agencies? And it does answer partly Uday's question too, which is, where would you find this fusion or intersection between software technologies and applications and maybe something else special amongst the interagency labs, where you have the opportunity, different business models. You can do open source commercialization or direct licensing, but have there been some thoughts of, future next steps around commercialization?
So one thing I'll point out is that we have taken concrete steps to enable these kinds of things. We have a robust SBIR portfolio, for example, that specifically has topics that encourage investment in the commercialization of software that Oscar has invested in the past, right, and that is relevant to our mission. And we are looking at other potential ways to enable commercialization and interaction with industry and other agencies. And so, from our standpoint, of course, success is determined by impact, and there are lots of different aspects of impact. And so, but this it's very important that we look at sustainability in a holistic way and in a way that's long term. And one of the reasons that we look at communities and the growth of communities around software is because we think it enables that commercialization and other opportunities. But of course, there are lots of different ways to enable those opportunities, and we like to look at all of them.
So I'd mentioned the work that we're doing with the E4S, commercial support team. I think that it's an experiment, right? We want, but we hope that it succeeds and that it's a valuable proposition, something that we could carry forward. We don't know for sure, but that's our goal. Beyond that, I don't see us opening like DOE Scientific Software Inc. I just don't think that makes a lot of sense for our, we're a science-driven organization with mission requirements, and so that I don't see. But I think it's worth mentioning that there are lots of avenues to measure success. Back when I used to code, we had credas with large industrial companies who were using some of the software we wrote. They used it, and in some cases they kept using it, and they kept up to date with the improvements we were making. They would update, maybe not every single time we did a new release, but every so often. And in other cases, they would take what we have provided, they would use it as a demonstration of capabilities. In one instance, it was going from sequential execution to MPI, and they used our software to show that they could run at scale with their problems. And then they said, thank you very much, and forked it and went on their merry way. And I still consider that a success. It's open source software with a permissive license. They have the right to do that. So there are lots of ways to have impact. That's the main message.
And we probably asked it that way provocatively, just to let each of the panelists know, because our ISVs, for any of them that are joining today, and for anyone else that's taken something commercially, all of these other topics that we've discussed today around product management, life cycle management, sustainment, and then the list of that framework that needs to happen on an ongoing basis, short-term and long-term for the future. ISVs understand that, because to commercialize something, it all has to be there, and you need to support your users on an everyday basis. So that's probably more of why we asked that question. Doug, I'll turn it over to you. You have your hand up.
Yeah, just really a couple of comments, and Mike really made that point about commercialization. There are a number of avenues in working with us to commercialize, and as Hal can attest, Oscar prefers that, I think has a policy that our software development is in general open source, subject to, of course, appropriate review. And Andrew can attest that many of our application codes are open source, so with very liberal licensing. The point being, a commercial entity could come in and fork off the code base and away they go. And that's fine with us. I think the interest, having been through this from my perspective, is as features by the commercial entity or improvements are made, it's nice to try to sync up where appropriate, and vice versa with the continued DOE development. So, arrangements like CRADAs or shared IP, help that syncing up, but aren't required. I do know of a few examples where at least we've been told that certain portions of our effort have been taken off and are working toward commercialization. And for us, that's that's success. It's not just don't swallow whole our technologies, but if you take pieces of it or use the concepts, that's still a success. Last thing I'll say per the application code base is, as Andrew said, they're focused on very specific problems, but our it's more than a hope or expectation is these codes will be general purpose and used for decades to come on science and engineering problems for the nation. And the user base may be, a few in science discovery to hundreds or thousands. So we will have failed if our codes are boutique codes that only, simulate one problem on one architecture. That certainly isn't the intent.
Can I add one thing to that? Because
yeah, please, Andrew, go ahead.
Because I was going to make a comment about that. So I do want to emphasize that, and maybe I wasn't clear about this, application developers, domain experts included, have a huge appetite for external users. Whether they have the means to support everyone that would want to use the code is a different question. But I know people who take vacations to train groups with their particular application, and people are excited about and are always courting. I just saw a talk this morning where offshore wind turbines simulation developed in ECP was being used by a group in GE to do some wake measurements. And it's people are willing to invest a lot of time just for the pride and for the, I think, affirmation, and also for a lot of information they get when other people use their application. So there is a tremendous market for, like Doug said, it could be small, like a community, like in climate, or it could be physics components that could be used broadly across. We have the example of CFD, but it could be anything from sort of particle transport to structural mechanics to molecular dynamics, to things that are sort of ubiquitous physics components that aren't owned by a particular set of problems. And that's something that always really interested me. People are willing to work hard on the side to get users. That's sort of a form of affirmation. So I think there's a lot to tap into there. I'm just not the one to say exactly how to do it. Sorry to interrupt you, Doug. I just wanted to elaborate.
Nope, that was great. Hey, I know we're up on time, and what I did want to do is do a quick wrap, because the goal of today's presenters and then the short time that we had for some additional Q&A was to really talk about the outstanding efforts that the ECP teams have done around lifecycle management and sustainment in each of these areas. Interagency, software technologies, and applications. And each one of the leaders here brought to the table the additional provocative questions of, how do we continue with the investment needed? How do we continue with the workforce development? How do we continue creating the right communities around this? And in supporting the people that are using it and the other users that want to continue. And that actually also goes out to the extended audience of industries and other agencies that have the ability to leverage these same capabilities. So I hope that the presenters here brought that to bear. I think they really did. The presentations are available in the chat here in the beginning. David and Susie left not only the agenda, but also the link to each one of the presentations. And I'm going to encourage others, like we do all the time, reach out to the leaders here.
And Dave, just to interrupt, we can go a little bit late because we have this Zoom call. Actually, they gave us till 3 Eastern time. So
super.
So maybe another, 5 or 10 minutes.
Do a little bit of that, and then I told Christian here we'd go back to his question and a few other questions that were still on the table.
Excellent.
So, okay, all right. I figured we might lose a few of the audience, so I wanted to make sure that they knew that the materials were available. So
excellent.
With that, we'll kind of end on that note, but we'll turn it over to Christian. You have your hand up and a question.
Yeah, it's half a question and half a bit of an experience report, right? Also related to this commercialization and commercial support question. So we've been using over the last couple of years, we started to use a contractor, right, to essentially contract out some of the kind of more standard software engineering tasks on some of our projects, including COCOS, right? So not like design work, but more like, our CMake thing needs to be updated, right? Here's all the stuff, where we use pre-C++11 things, and you need to replace them all with C++11 things, right? Replace our pthread use with std_threads use, right? Stuff like that. And that has been really successful, right? It has been offloading, kind of work which isn't necessarily valued that much in a science position, right? And freed the person, our DOE developers to do more, actual research development, right? But the other thing that did is this contractor now has a lot of expertise with our code base, right? It has a lot of expertise with how to do things in our code. And that makes him actually somebody, that makes that company a company we can recommend to other people to, if you need to fund somebody to do some work on your stuff for, with our things, you can go to that person. You can't really fund us, but you can fund these people, right? One thing we found, however, is that it's not completely trivial to find funding to do that kind of offload work, right? Because different funding streams are, some funding streams are very restrictive in terms of whom you are allowed to give money, right? Which makes that hard. So it's something I think we need to keep in mind in when DOE puts out, programs that we might be allowed to use some of our funding for getting much cheaper, contractors to do some of the boring work, right? But the necessary work.
I guess that's a vote in favor of what Amitabha was suggesting. So it's interesting.
I think everyone's going to agree on that, Christian. In addition to that, and by the way, everyone has challenges around the financials. So, when we say we have shared challenges, today's investment in long-term continued investment, whether it's industry or agency, any one of the agencies, I can assure you that that's a topic that we always hear, talk about amongst each other, and it's just ongoing dialogue. Are there any other, let me go through just for, I see Paul, you have your hand up.
Yeah, thank you. So first, thank you to all the presenters for the wonderful presentations. Really enjoyed the session and some of the discussion here. So my question is on the application side. So I guess targeting Andrew here, and specifically to the point about applications not being finished at the end of the project. So one thing that I wanted to bring up and just sort of get your thoughts on here is that sort of in addition to the normal things of fixing bugs and adding new features, one of the positions that we're in specifically for the ExaSMR project, and I suspect that others may be in a similar situation, is that we've done a lot of our porting efforts for GPUs, but for a variety of reasons, most of that work does not exist on a main branch of the code. And so we're likely to reach the end of the project and not really be in a state where that's sort of like a public, fully vetted product that we can push forward. And so I think one of the risks is just that in the absence of any sort of funding to keep those things going, that's something that we risk just sort of being off on some branch. And it's like, oh yeah, once upon a time we did that GPU port. And so I was just curious to get your thoughts on, one, how many application teams are sort of in that similar situation, and just how much thought has been given to that issue in particular?
Okay, so we thought a lot about this, and our fear, and one I think of the possible downsides of our performance KPPs, is that it encourages people to eviscerate their codes in this performance sprint, and then no accountability for tying it all together at the end. So one of the principal themes that we developed, and to me it was, I think, one of two driving themes for a project extension, which might or might not happen. We've talked about this on our internal telecons that you've heard as a local PI, is exactly that, which is a sort of software engineering component in order to bring changes into a main branch, in order to define abstractions that are more sustainable, whatever it might be, such that the code artifact that comes out of ECP is of the quality that you would expect it to be for the level of investment. And the fact that and a lot of people are in this situation, okay? You're one of many. And it does concern me. And I'm glad you brought it up again, actually, because, well, it looks like Doug's still on, that's good. But it's something that we've juggled with the idea of really emphasizing, if not sort of enforcing on a project by project basis in this sort of final stage. So I'm glad you raised the issue, and sort of stay tuned, I guess is all I can say.
So thank you, Paul. I thought there was one good point here on the housekeeping items that Christian mentioned earlier, and Amy, you were making some comments on it. And I thought some of the rest of the panel may want to add to this, but I guess the comment was made that, is it during the hardening phase of development where we really take care of all housekeeping items? And I think that many of us will say yes to that, but at the same time, I'm just going to speak for one particular item that may be more industry focused than maybe even within DOE or ECP focused, but security these days must be done not only just in the hardening phase, but we need to do it in fact architecturally upfront and throughout. So I'm just using that as one example, and I think there are some other examples that in software technology and application development that the housekeeping items cannot be all left until the end, although that's in the hardening phases where we may find things that we do need to fix before frustrating users at the end of the day. But maybe I'll open that back up to Mike, Cal, and Andrew and get your thoughts on, there are a lot of things that can fall under housekeeping. I just use security as one example, but in software development, we don't always want to leave everything until the end.
I can just speak anecdotally from my own life experience. The very first Trilinos life cycle model had this definition of you did all this kind of preliminary skunkworks development, didn't care much about testing or documentation or usability. That there was somehow magically, when you're all done figuring out what it is you're going to do and you've got this kind of amorphous software product, you're going to magically spend your next 6 months cleaning it all up and making it available. That never worked, never. And so everything that you want, I think, needs to be baked in, at least to some extent designed in from the very beginning, or you never will go back and do it. I worry about projects that have done this branch that's completely separate from the rest of the code because not that for lots of reasons. One is that the mainstream code continues to evolve, and so by being separate from it, you now have an even more difficult integration process because what you started with isn't the same as what it is today. I don't know, that's just my life experience. There are some things you can do in a kind of placeholder way, perhaps, but almost everything, if you're going to have a real chance to succeed, you need to be serious about all these activities from the beginning.
I suppose I'll just add that, there is a classic trade-off in science, right, between enabling flexibility and adaptability in exploration, and also the classic advice to begin as you mean to go on, right? And so, in research, we like to, anticipate failure but plan for success, and you have to balance all these different factors. So I think one thing that is clear is that it is important for people to be cognizant of and track their technical debt as a term as they go on. So they have some feeling about how much they're accumulating where and can deal with it appropriately. And so I think that while there's always going to be a different balance in how you prioritize things and where you retain flexibility and how much work you put into hardening, you do want to be cognizant of and explicitly cognizant of what that technical debt is that you're accumulating, so that as the project continues and if it's successful, you can hopefully make a well-informed decision as to how to prioritize that kind of work.
So I'm going to guess, Paul, that you support a user community with the multi-core version of OpenMC, and that there are changes being made on that branch, as Mike pointed to, as you were doing all of the GPU work for targeting, in particular, the Aurora system, and that those two are out of sync, and that it's kind of hard to keep them in sync given those two different activities. Is that true?
Yes, Mike's comment absolutely resonated with me.
Yeah, but because you have a user community, it's not so easy to always align them. I don't know how many people, I know you have groups using the code for a wide variety of different things. So that would be a good place where investments in sustainable software engineering would make a lot of sense, I think, honestly, even beyond ECP, because the impact of OpenMC is very broad. We're talking about enabling a lot of different science, you know, fusion and fission and charge flow and whatever. Okay.
Christian, back to you for a question.
I think one of the big problems, right, we have or had in particular also in ECP is that, and why we end up in this scenario where this is all just on branches, right, is that at the time where the application started working on something, right, it wasn't quite clear what the right approach is, right? So, you know, whether to use OpenMP or Cocos or write everything in raw, HIP, and Siegel and whatnot, right? And so if you don't know whether it's the right approach, right, you don't want to pollute your main branch with that, right? And your main working stuff, you know, all your users are actually relying on, right? Because if you made the wrong decision, backtracking, right, is going to be a huge cost as well. And I think that was a big problem there. That's why within the NNSA applications, I think that worked out a bit better, right? Because we prototyped it in a couple applications, and then at a program level, we kind of made the decision, this is the way we're going to go, right? And we committed to it, and that means everybody else then followed by just putting it directly into the main branch, right? And but what we need for that is we need, you know, trustable solutions, right? You can actually commit to by the time you start to do that, right? I think for ECP that was basically impossible, right? But it's something going forward, right? Other apps who are following the lead of ECP, you know, might be able to do, right? They might be able to say, okay, this technology is proven, we're going to commit to it from the beginning and not develop that on a side branch, you know, as a side project, but, you know, port our main code right away to it. But I think that was the big problem, right? Why we ended up there.
Comments, thoughts from Mike, Cal, or Andrew?
Yeah, you know, so there was also a comment from Dana Robinson about one throwaway. Yeah, it sounds attractive, right? It sounds really appealing that you can do this prototyping. But I think you have to be really careful about how long you go, you know, on that feature branch or whatever it is, or, you know, and if you're years away from, you know, when you forked it, I think there's a tremendous risk associated with that it's really hard to recover. And we generally don't get paid to throw away something and you know, get it right the second time. That's really hard to justify. So I don't know. I would just urge a lot of caution with that kind of approach. I completely agree that, you know, you can't put it all in, you can't do experimentation on the main branch. That doesn't work. But the frequency with which you integrate, or you have some kind of, you know, holistic plan for how to integrate, that's really important.
Any other questions coming in? I'm looking across the audience right now to see if anyone has their hands up. No? Is there anything that we missed in the chat? I was trying to look through, and I'm going back to Susie and David too.
I don't think so. I think there's been some discussion, but I don't think there's anything outstanding. So
I know there's one item on Rick asked earlier around model-based systems engineering, and actually the question was more focused on some integrations and interoperability, but I think that one may even be a broader topic across a couple of agencies, even outside of today's session. So
I can ask a question if you want. This is Richard Brower.
Yeah, Richard.
I keep wondering all the time, this is lattice gauge theory, whether we're different or the same. So let me tell you what I think sounds different, but maybe everybody will say this is the same. I mean, worldwide, there are a lot of people working on lattice gauge theory. So if you look at application codes, I don't know, I would have a hard time counting, but there are probably 10 major application codes. But everybody also is openly using each other's, borrowing ideas, improving algorithms, and both sort of collaborating and cooperating. And I think this is very productive. It means that we don't have all our eggs in the same basket. We also don't demand that every application group be finely tuning the application for everybody else's use. So it's a kind of marketplace. It doesn't mean that we don't have sophisticated portable codes, but we don't have a single philosophy throughout this community, right? Now, if we even collapse to the US, the community that is in exascale, that is usually framed as 3 different code bases, which we are gradually, I would suppose, sort of moving into a single code base. Oftentimes there's this sort of production code, and then there's this application. It's what Andrew called downstream analysis. And that may be very diverse and so filled with physics knowledge that it'll be a long time, maybe almost never, that code will be merged into the high performance exascale code. So anyway, I'm just saying that kind of community activity is, I think, productive. We certainly need help to have experts to keep it doing. The best thing is probably people in labs who can get jobs. I love this idea of a career path. I think there's expertise that need a career path. They're extremely good. And some of these people, by the way, jump ship and work on a totally different project, right? My graduate students are now working in NVIDIA and are assigned to do things in molecular dynamics and fluid dynamics and so on, and continue to work on lattice gauge theory. So there's an expertise of application which is not specific to an application, once you get good at it. Anyway, I'm just describing this sort of community thing as being a little bit more, I guess, market oriented. I don't know how to.
Yeah, no, well, I mean, I see this, so I think that's a fascinating point.
Yeah.
And I see it as under the general rubric of there is value to redundancy, and economy of scale isn't always better, and that it isn't irrational for people to want to do things themselves. There's also value to it. I think there's always this assumption that if you have a dependency, that is a good thing because it was something you didn't have to do. And that could be either a dependency on software, or it could be you using somebody else's lattice QCD code. You didn't have to build it yourself. But it's not irrational for a number of, oh, go ahead, sorry.
There's a lot of reuse. I mean, for example, when NVIDIA, when we realized GPUs are important, we developed extremely elaborate, with NVIDIA's help, application code, which was used in Japan and Europe and so on. And then this is migrated into other codes, sometime changing it entirely to sort of a C++ interface, but it was reused. It wasn't started over. Right?
Well, that's good, but what you're basically saying is it's not necessarily representative of a failure. The fact that there are 10 duplicative activities going on. And I think we have to recognize that. I think sometimes it is good to do something yourself.
How do you support that kind of success? Or maybe you don't have to, you can say it's already supported, but I mean, it does take,
Well, I don't know the answer to that, but I think it's a good point that there is value to it.
A little bit more like an open software consortium, right? It's like saying, out there are a lot of people and you keep borrowing ideas. And that's, I mean, after all, we know, Unix didn't disappear because it didn't have a company behind it, right? I mean, it's not the only example of a community developing sustainable software, right? So I don't know what that sustainable software concept is, but I think it does work.
Yeah, so I mean, let me just add to that quickly, and also maybe tie this back into the question that David posed at the beginning of the panel about challenges. So I mean, I can't give you a definitive answer, but what I can say is that we are definitely aware of the set of trade-offs here that are really important. So there are trade-offs in efficiency and lack of redundancy within an ecosystem versus the resiliency in an ecosystem and the flexibility in that ecosystem and the ability to explore. And so while I can't tell you exactly what the right answer is, I can tell you that we are aware of that trade-off. And from the funding agency perspective, we do try and structure programs to capture that balance, right? To not have the pendulum all the way on one side or all the way on the other, but to try and arrive at some place in the middle that is a reasonable balance between sort of overall efficiency and lack of redundancy on the one hand, right, but also resiliency and flexibility on the other.
I think one of the things that this promotes, close to my heart, is that algorithmic development. I mean, there's been basically 20 years of developing multi-grid, okay? And it's been competitive and it keeps changing and solvers keep evolving and so on. We agree on the problem, okay? The problem hasn't changed. But because of this diversity, it really has progressed over decades to a much more innovative approach from the mathematical and theoretical side than it would have happened if there were kind of a software group and an application group and then a separate algorithm group, okay? It's the fact that those walls are actually very permeable meant that there's a lot of progress that way over a long period of time. And I don't see how you would do that if you had too much of a top-down organization, right?
Well, and this is precisely the motivation for a large part of the structuring of our overall portfolio, right? We have basic research, right? But then we also have partnerships.
This would be a compliment to what you're doing. I'm not saying that, but I'm just trying to make sure that this is part of the sustainability ecosystem.
Yeah, exactly.
Yeah, thanks. No, I appreciate Oscar's been very helpful over and over again in sustaining for us this kind of diverse development. Yeah.
Great.
David, just a follow-up comment on Richard's point. Can you hear me?
Yep, we sure can.
Yes.
So this may be obvious, and Andrew knows this, but when we worked with our DOE sponsors to select applications, one constraint that we had that our sponsors agreed with was, not 5 cosmology projects, but 1, and not 5 astrophysics projects, but 1, because of time and money. And so, what we wanted to see was, multiple scientists coming together with, potentially their own codes that have their own strengths and weaknesses and being able to interoperate in the same environment. So in other words, that's maybe co-opetition. But I think we've seen some nice evolution there in terms of, I'll call it an end station for, a given domain where, hopefully friendly competition. I think the things to kind of fight about are algorithms and models and not so much software. But nevertheless, in ECP, we did have the constraint, kind of one domain, one app project per domain. And that was not easy for the reasons that Andrew cited and you did as well. Yeah, right. I also think there's a benefit to that as well. I could see pros and cons.
I mean, they're not as separate as you think. A given postdoc or scientist may actually go and use all 2 or 3 different of these application codes in the process of a single piece of research, right? So they're all considered as a resource. I mean, they're not.
And if they're part of the same kind of sub-project in ECP, all the better, because they're able to benefit from multiple tools and technologies.
They're separate in terms of, some effort put in, but they're not separate from the scientific point of view. People use, a single person through, maybe 2 or 3 years may use 3 or 4 of these application codes because certain ones are expert and good at that, okay? We do this all the time. We don't say, this is the application code you should use. We say, look out and see all of the tools that are there and use the ones that you need at that part of your development, right?
Agreed.
So it's in some sense, it is a single application code. It just has diverse branches, right?
So I think we're at the end of our extended time.
Anyway,
here.
thanks for allowing me to
No, fascinating discussion. I wish we could spend the day.
It's not as different as I suppose. There must be many communities that are doing similar things. I would hope.
Dave, you want to wrap us up?
Yep. I'll even end on that one, Richard. We're more alike than we are different.
No, I think we are. We just have
Yeah,
to
we are.
understand the best practices and
Yeah.
and figure out how we spread them. Yeah.
And I just want to put another exclamation point on the outstanding work here that the ECP team is doing around lifecycle management and sustainment. You know,
Oh, absolutely.
I think these topics that everyone is bringing up here today and the questions that everyone had, very thoughtful questions, is all around one other piece that we said early on, but I'm going to end on this one, which is the continuous learning part of what we all do. When we continuously learn and we put that back closed loop into our processes that we've created here around life cycle management and sustainment, we're going to get better, and we're going to get better faster. And we'll get better faster with, I love the community thought process that all of you had going on in each of your presentations. So I wanted to thank also the ECP team for letting me kind of help moderate today, and then thank the entire audience. I just looked through several times here through the entire audience that stayed on through today's discussion. And you know, this discussion around life cycle management and sustainment is hugely important to you know, us in industry and across the agencies too, because it helps us with the work that we do every day, makes us more productive, and then helps us to focus on the bigger work that we do, the amazing engineering and scientific challenges that everyone's working on. So thank you. Thanks for the time today. And then Susie and David, sounds like we'll have a wrap for today's discussion.
Yep.
And then Michael and Andrew and Hal, thanks again for your great presentations today. And they are available. The link's been posted several times in the chat for anyone that wants to go back to it. Okay. And thanks again. And have a great afternoon, everyone.
Thanks, everybody.
Thanks,
ECP
everybody.
is a wonderful simulation. What would we do without it?
Well, great. I might just mention for those who are interested, at 4, we have another session called On-Ramps to ECP software and applications. And some folks here might want to attend that too.
Thank you.
See ya.
Okay, I'm ending the recording. Thanks.
Yep. Thanks, Earl.
Bye.